Hi everyone, welcome back. So what we're going to do now, now that we've kind of talked about basic hypothesis testing, so far we've just talked about it with a single categorical variable. There were some important topics that we skipped over in doing so that we're now going to come back to. And so we're again in our section 4 note packet. We were talking about this example where we wanted to see if there was evidence that students did something other than random guessing when answering this question: how many years do women spend in school worldwide? Compared, and it was given in the question that men on average spend 7 years in school. And so we have some data that we collected way back in week 1 where 15 of you said 7 years, 32 said 5 years, and 9 people said 3 years. And so we had kind of gone through all this. We'd written out the null hypothesis corresponding to random guessing. So that means if people were just randomly picking one of these 3 options, then on average a third would get that question correct. And so now we want to answer that hypothesis test question just using something that we did before, which is a confidence interval for the proportion. And so this is kind of review, so I'll go through this pretty quickly, but we could go through with our 4 steps: prepare, check, calculate, conclude. And so prepare, we just want to know what p hat is. So remember, p hat, that's our notation for the sample proportion. Based on our data, there's 56 students. 15 got it right, so p hat is just 15 over 56. I'll put that in decimal form, and so that's 0.2679. N was our notation for the sample size, so that's just what's given on the bottom of p hat, and so n is just 56 because we had 56 students answer that question. All right, we can now check our assumptions. And so again, not that it's not important, because it really is important, but we're going to assume independence holds for now. We'll get to that assumption either this week or next week. And let's check our sample size condition. And so we want to check to see if n times p hat is bigger than 10, which it is, because n times p hat is 15. We also want to see if n times 1 minus p hat, if that's bigger than 10, which again it is, that would be 41. And so our assumptions hold. We called this the success-failure condition. Also holds. So we could go ahead and proceed with construction of a confidence interval for the proportion of students who answer this question correctly. This calculate part is usually the easy part, or at least it's easy if we've set it up correctly, because we just grab our confidence interval formula. It's 95%, so we're going to use 1.96 there, and then we just plug our sample proportion and our sample size into this equation. I'll just do this quickly. You're welcome to follow along or not, and just use what I get. And so my interval goes from 0.15 to 0.38. And so the last step is to write a conclusion so that someone can kind of interpret all of the work that we just did. And so this prompts us to write a conclusion using the informal interpretation. And so remember, our informal interpretation was just something like a range of plausible values for, we always want to put this in context, and so we want to say what our proportion actually is. So it's for the proportion of SLU students who answer, I'll just call it the gender school question correctly. Is between 0.1519 and 0.384. Okay, so now we've got our interval, which remember we're thinking about informally as just a range of reasonable values. Based on that interval, which I'll copy to the next page, so we have our CI is from 0.1519 to 0.384. Remember our null hypothesis was that the proportion was a third, or 0.3333. So take a second to go ahead and pause the video and think about this question. So can we conclude that the proportion of SLU students that answer this question correctly is different than 0.3333? So remember, we're interpreting this as a range of reasonable values. And so use that kind of informal interpretation to help you consider answering this question. Okay, so hopefully you paused the video and at least thought about this for a sec. What we need to do is check to see if P0, which was a third, is in the interval. We see that 0.333 is in this interval because it's greater than 0.1519 and less than 0.384. Because it's in the interval, that means it's one of these plausible values. So it is a plausible value. And therefore, we can't conclude that the proportion of SLU students who answer the question correctly is different than a third. Because a third is a plausible value, so I can't say that it's different than that. So this is kind of another way to do a hypothesis test, but just use what we did before and do a confidence interval. Albeit this is still a less common way of doing things. So if you usually read like an academic journal article, they'll usually do kind of the p-value method, but this is another kind of perfectly valid way of thinking about a hypothesis test. The last thing on here is just to get some of our notation kind of down, since now we've kind of had a lot of it. And so we've had a P with a little hat on its head, and we've had a P with a little 0. And so we've covered all these before, but our P refers to this population proportion, usually unknown. So we don't know the proportion of all SLU students who answer that question correctly because we didn't do a census. Our P hat is our sample proportion. This is the thing that comes from our data. And so we collect some data, we could compute the sample proportion like we just did, 15/56. P naught is the null proportion. This is the one that's in the null hypothesis. And so this is what we're testing. We want to see if there's evidence that that this population proportion is different than whatever we specify in this null proportion. In this case, it was a third because we wanted to see if there was evidence corresponding to non-random guessing in that multiple choice question, and there were 3 total choices. Okay. So where we're going from here is we're going to continue to kind of go over some topics that are important in hypothesis testing that we originally had skipped over. And so as always, definitely let me know if you have any questions about any of this.